Okay, so this is the first part of lecture 14 on advanced usage of Unix. I'm a little jet lagged. You can see up in the corner it's 3:09 in Paris, but it's 6 o'clock in Eugene, so I feel okay. So I'll post this and then I'll post a second part to the video, which is me just exploring a script. So here we go. Um, let's see, I think I've shown this slide a couple times. I just wanted to show it once more, that when you invoke and by the way, this lecture is just going to be a bunch of random things about Unix because I want to make sure that you guys have a kind of a complete understanding of how to deal with Unix. So this is an example of the sort of random thing that you'll be seeing over a series of about 20 slides. This slide I think I've shown before, which shows that whenever you invoke a command, you can access the return value of that command in the next shell invocation with the $? So we call a.out. It works successfully, so it has a return code of 0. And if we say echo $? Then we've got a return code of 0 printed because $? Is the return code. If we run a.out and it doesn't work, then it gives us a return code of 1, and we get that when we print $? Once you've invoked a command, if you don't get it right away, the next command is lost. So there's no way to go back and find, or at least no way to my knowledge to go back and find the return values of previous commands. Okay, so then the next couple slides we talked about in the context of C, but I want to turn around and put them in the context of Unix. And so in C, we talked about fprintf. It was a little quick at the end of the lecture, and so I want to talk again about fprintf. So the idea is that in Unix, everything having to do with printing to the terminal and reading from the terminal is done with file I/O. And so that's actually an interesting idea, right? That when you're printing to the terminal, you're reading from the terminal. The Unix views that as interacting with a file, and it just happens to appear on the terminal. And so the keyboard and the screen are files in the file system. At least they were. I think this is how they were implemented. Certainly in the 1970s. In today's world where they've got these fancy GUI desktop managers, I think the terminal is almost more emulating what the world looked like in the 1970s. But regardless, as a programmer, that's how you interface with it. And so then we've looked at this slide before. This talks about the standard streams. And so here's a definition that I will again read from Wikipedia. It says the standard streams are pre-connected input and output channels between a computer program and its environment. Parenthetically, typically a text terminal because that's where everyone uses this when it begins execution. And so there's 3 streams, and we've talked about this. Standard in is the standard input, standard out is the standard output, and standard error is the standard error stream. And so we said, well, what mechanisms in C allowed you to access the standard streams? And so then we said, well, printf does it. And then we went forward and said, well, actually, there's another program called fprintf. And it's just like printf, but it goes to streams. And if you call fprintf and say you want to go to the standard out stream, that's the same as printf, but you could do it with the standard error stream, which we've done a little bit more over the term because that is always guaranteed to print. And then in some of your projects, you've done fprintf to fout, where fout is something pointed to by the file, some file struct that you've created with an fopen. Okay, so that's a little review on standard streams. How does this work in Unix? So Unix allows you to manipulate the standard streams, and we've seen examples of this, certainly in the greater scripts that I've produced. So if you use the greater than symbol, that will redirect the output of a program to a file. So if you say ls and redirect it to output, then the contents of ls will end up in the file output. Echo is a command that will, whatever you type afterwards, it will just print it. Here, let me just do it. Echo, this is a file, then it just prints, this is a file. It can be useful because we'll have environment variables. So like, if I say export, x equals, Hank Childs, and then now I want to know what the value of x is, then I would say echo $x, and then $sign evaluates what is the value of the variable. And so where you'll see echo be used a lot is, well, just to create, if you have a script and you want to print something, then you can have the script print something with the echo command. Also, if you want to know what the value is of a variable, then you can use the echo command to do that. If you look at the greater scripts, I'm using echo a lot because I'm trying to communicate with you. Now I'm going to do this, and then I do some commands, and oh, it worked. And so then I'll have echo commands to do that. And so echo is being put in the script to send print statements to you all. And then the cat command, so here's another example where I'm saying cat file1, file2, and redirecting to file3. And so cat, we've seen cat many times where we'll print the contents of a single file, but here it's printing the contents of 2 files. That's fine. Cat will take multiple files and read the first, print it all out, read the second, print it all out. But we're redirecting that to a new file, file3. And so that's essentially taking file1 and file2 and putting them together in a new file, which is file3. So the less than redirects file to the input of a program. And so I think actually you can just say Python and give it an argument. But there are various times when you want to redirect the input as if someone is typing it at the terminal, except for the program is taking this file as the input, pretending that it's coming from the terminal. And there's some stuff in here that I think is interesting, but I've presented a few times and no one else seems to think it's interesting. When I use Python, I type Control-D to end, and Control-D corresponds to the ASCII character number 4, which is what's used by Unix to designate the end of a file. And so Python quits because when you do something like this, and it gets the end of the file, that's character 4, Control-D, and so it says, well, I'll quit too. Okay, and so I think that we talked about this in a lecture, but I haven't presented slides on this. If you have a double greater than, then that concatenates the output of a program to the end of an existing file. Or if it doesn't exist, it creates the file. So here in my example, I said I'm starting the file, and I redirect it to file 1. And if there was a file 1 right here, this would overwrite that file. And then the second one, I am now redirecting with the concatenation, double greater than, and then when I print the file, it has the first line and the second line, and the second was printed to the first. So let me just do that real quick. So I am starting the file to file 1, and then I am adding to the file to file 1, and then if we cat it, we get that. But if I were to do this and say, I am now starting the file again, and again, that's just a single redirection right there. If I cat file 1, you see it's overwritten what was there. And but if I were to do that one more time with a double greater than, and now I cat file 1 again, then we've got the statement twice. I meant this to say I am now starting, I am not starting. Anyway, so hopefully that's clear. So then this is an example showing where redirection of standard out goes a little bit wrong. In the example, I've made a directory, I've cd'd into the directory, I've created a file, and I've said ls of file 1 and file 2, and I've redirected it to out, and but the redirection doesn't quite take. And the reason why is because we've got file 2, which doesn't exist, and ls is going to tell us that there is no file f2. If we look at the file that we directed the input into, out, then it successfully contains f1. And so what's happening here is ls is using 2 streams simultaneously. It's using the output stream to print the files it's successfully found, and those are the ones that are being captured in the redirection of the standard out stream into the file called out. It's also, when it gets something like this, it detects an error, and so it's printing its error to the error stream, and because the error stream is different than the out stream, the redirection of standard out to this file doesn't affect the printing of error messages. So that's what's going on there. We of course could do it differently. So here's our same example, but now I've said I want to ls f1 and f2 and redirect standard out to out, and then redirect, and here it says to out error. And so in Unix, the standard out stream is stream number 1, and the standard error stream is stream number 2. And so if you don't add a number, then it's assumed to be standard out stream 1, If you add the number 2, well, then you can get to the standard error stream. If I would have put right here 1 and the greater than, well, it would be a no-op. It would be, that would just be the same thing. But this, because the 1 is implied there. And so when we do this now, ls f1, f2, redirect to standard out, and then redirect the error stream to out error, then when we don't see any output from this, right, so we press ls and enter, and you see we get a prompt, but then if I cat the out error directory, then we see now f2. We can actually do an all-in-one thing, and so here we're saying ls, and this is the same above, and then we say ls f1 and f2, redirect it to standard out, and redirect standard error to standard out. And now the two statements are both being sent to the same stream, and when I look at the out file, we see them together. I think I started at 40%. I need to get plugged in. I guess this will be a beat the clock situation that I can get this finished before I get down to 0 on my battery. Okay, so this I've now bounced back to C, and I'm going to talk about something in C that you will rarely use in C. You probably will do it in 4.15, and then even if you're a C programmer, you might not do it again for a long time in your career. And but it turns out that the shell uses this construct, and in the shell it's super useful. So I'm going to start by describing what happens in C, and then I'll build up to how the shell uses it and what you can do in the shell using this construct. So the construct is called fork and pipe. And so the idea behind a fork is, it's as if you come to a fork in the road. You've got one thing, and you split into two. And so you can go and call this function in the C standard library called fork, and it will take your currently running program and make an exact duplicate of the currently running program. So when I was doing my visual like this, and I had the fork in the road and I split, this would imply there was two, and each one went one way. That's actually not what you should think about. You have one, and then after a fork, there's another. And it's identical, and in fact, the only way that you can tell which is the original and which is the copy is that when you call fork, it has a return value, and I think maybe the original gets a return value of 0, and the copy gets a return value of non-zero, or something. But then you have two programs. And then the neat thing is you can connect these two programs. And so you can say if this is the input stream and this is the output stream, you can connect them. So when this program here is outputting, this program here is taking it as input. And that connection is called a pipe. And so if you have a program that you've forked, you can connect them up via a pipe, and the output of one becomes the input of another. So it's really only used in special occasions when you're doing C programming, when you want to connect two programs, and of course it's one binary, right? And so it's well, I don't know. You'll learn more about it in 4.15. But the shell makes use of this, and it gives some really outstanding functionality. So first off, oh good. So we will look at it in the shell. So here are two programs, and so the first program is called printer, and it's a trivial program that prints hello world. And the second program is called doubler. Now I've had several functions called doubler in this class, and they always take an integer and then multiply it by 2. This is doing doubling in a different way. This is getting characters from the terminal or from the input stream from standard in. That's actually a really important point. It's from standard in, which is typically the terminal. In this case, we're going to have the output of the first program, printer, connect to the second, which is doubler. And so the input is going to be standard in, which is typically the terminal, so you type at the terminal, but now is going to be printer, and then doubler will take that. So it's coming from standard in. And so this is a way to get one character at a time. I don't think we've lectured on get C before, but I mean, it's trivial. You call get C on some file stream, standard in, and then it gives you one character. And so this says while the character is not end of file, print it, twice. So we're saying printf %c, and this character that we get, we're printing it 2 times, and then we call it again, and we keep going. And so I compile them, and then here's the neat thing. I call printer, and then I do this vertical bar. I don't even know what the vertical bar is called, because if I was talking to anybody, I'd call it a pipe, because this is how you connect the output of one program to the input of another in Unix shells, is you use this vertical bar, the pipe. And so I would read this as, if I was saying to someone I want them to type this, I was dictating what I wanted them to type, I'd say /printer pipe /doubler. And so the output of printer, hello world, is being fed into doubler as input, and then doubler is reading the characters one by one, and every character it reads, it prints twice. So this example is probably not enough to get you excited about pipes, but I'll show a few more, and then in the second part of the video I'll show even more, and then there'll be some in the homework as well. So one way that pipe is really useful is when you use the grep command, and so grep will look for a pattern. And so, here I've gone to my documents directory, and I've done an ls, and I say I want to grep for ppt. And so I've got lots of files in my documents directory, a lot of end with like doc or .docx, but I just want to see the ones that end with ppt. So another way I could have done this is I could have said ls-l star.ppt, and that wouldn't have gotten the ones that have pptx. I also could have said ls-l star.ppt star, and that would have gotten the ones pptx. But this grep is really useful because you can use it in a lot of ways, and so in this particular example it could be replaced by a wildcard, but it can do the things that wildcards are doing in that case, and it can be used in a lot of other ways as well. So grep says just look at everything that comes in, and if on a given line you see that pattern ppt, then keep the line, and if it doesn't, then discard it. And so we'll look line by line, and if a given line doesn't match the pattern, it gets discarded. By the way, very, very useful, there's an inverse to grep, or an option to grep, which is grep-v, and that does the opposite. So it says, if you find this pattern, throw it out. If you don't find it, then print it. And I use grep-v about as often as I use grep. Okay. Another really useful command is sed. So here I'm going to show you an example of sed right now. I'm going to use my earlier typo and fix it. So I'm going to cat, sorry, my laptop is bouncing around, file1, and I'm going to pipe it to sed. And with sed you can replace a pattern, and I'm going to replace the pattern not with now. And what do these mean? So the S means substitute. To be honest, I had forgotten until I looked at my own slide what S stood for, and I use that S every day. I don't even think about what it means for anymore. And I use it every day because this sed program, which does replacements, is built into VI, and so I use it in VI to do search and replace. So here I'm going to say cat file1, and then I'm going to sed not for now, and if I invoke this, then instead of saying I am not starting the file again, I'm said I am now starting the file again. And if I wanted to, I could redirect this to some other file, file2, and if I cat file2, well now it has the right stuff, and maybe I even go and say I want to move file2 to be file1. And so sed will take a pattern and replace it with another pattern, and at the end you typically put a G, which means you want to replace everything. So if I, here, let me do it again. Go to file 1. Now it says now, and I'm going to put not twice. And if I were to run this, now replacing not with now, but not putting the G, whoops, let's just take out the file 2. You see it only replaces the first one. And so the G says replace everything on the line. So the first time without the G, it only replaces the first one. The second time, here's the original file. So the first time, here's the original file, now, not. And the first time without the G, it only replaced the first one. The second time with the G, it replaced all of them. If I would have had 3 or 4 with the G, it would have replaced all of them. So again, sed is available in VI, and so if I were to go into VI, I could say %s, and the percent means all lines. Actually, I won't do well, look, I'll do a %s, and then I'm going to replace not with now and do it globally. And that's actually going, at least at one point in history, it would go and invoke sed and then take the output of sed and put it up in the VI session. Now my guess is actually VI just has its own implementation of what sed does, but I don't actually know. You don't have to do %s. You can give it a range. So here in the example it says lines 103 to 133. This can be really useful if you just have one function. You want to make replacements in one function. So here I'll just say I'm going to replace from line 1 to line 1, and I'm going to replace now with not. And so now I've got nots in the top line and nows in the bottom line. So this is somehow shifted to a VI tutorial. What I really want to show is that, with pipes, with sed, you can actually change the contents of the file. And you'll see that pop up in the example I do in the next video. I think we've talked about this at the beginning of the class, which is wildcards. And so the $ is a wildcard that will replace things with as much as you need. So here I've said LSC star, and so each of these has everything that starts with C, doesn't matter how many characters follows, has done a replacement. Here it's doing it the other way, LS star Z. Here it's looking for a double E, and here's looking for people that have two E's in their name. And so this is just doing pattern matching. There's also a version of this where instead of star you use question mark, and it matches exactly one character. The last things that I just want to make sure people are aware of in the shell, if you do ls and then you press tab, then it will do autocomplete. So if I had pressed LSFP and tab, then I don't have to type in the rest of that statement. It will complete it for me. That's really convenient. In this particular shell, when I press tab twice, here I'm going to do it again, 1, 2, then it's showing me the options of how it can autocomplete. Not all shells do that, and if you press escape equal, it will also show you the options. So then if you press Control A, it'll go to the beginning of the line. Control F goes forward one character. Control B goes back one character. Control E goes to the end of the line. Control P is the previous command. Control N is next. And if you ever want to search, then you can press Control R and it will search upwards for commands there. So those are all useful and interesting, ways to speed up your manipulations in your shell. Okay, that's it for the PowerPoint version of this lecture, and then again I'm going to come back with a second half and go through a script that I wrote. And then just to make sure everyone knows the plan, this week in lab, the TAs are also going to talk about Advanced Unix, and I will be posting Project 1C as well, which will be doing manipulations with Advanced Unix. Okay, au revoir everyone.